Hello everybody, in this video we're going to talk about how to solve quadratic equations by using the quadratic formula. So we see our quadratic formula here in yellow. X equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So what do a, b, and c stand for? Well, it comes from our numbers in our ax squared plus bx plus c equals 0 standard equation for a quadratic. And really there's a process of, we could use completing the square to derive this quadratic formula. And if you want to check out kind of how that happens, where this quadratic formula comes from, you can check out the card in the top right hand corner right now. But for now, we're going to use this formula and we're going to solve 3 examples. We're going to look at when we're going to have 2 real solutions, 1 real solution, and then when we're going to have imaginary solutions. So we'll jump right in to example 1 where we have 2 real solutions. So we start off with 3x squared plus 4x equals 10. The first thing we want to do is make sure that's equal to 0. So we're going to move this 10 to the left side. So now we have 3x squared plus 4x minus 10 is equal to 0. And now we're ready to use our quadratic formula. So we have x is equal to the opposite of b plus or minus the square root, b squared minus 4ac all divided by 2a. So now we need to identify a, b, and c. So a would be 3, b would be 4, and c would be negative 10. And now all we have to do is take those values and plug them in. So we get x equals the opposite of b, well, b is 4, so that'd be negative 4, plus or minus 4 squared minus 4 times 3 times negative 10. And we're going to divide that by 2 times 3. So this gives us x equals negative 4 plus or minus 4 squared is 16. Now notice we have a negative 4, a 3, and a negative 10. And we're going to multiply those 3 numbers together. So since we have 2 negatives, this is going to result in plus. And we have 4 times 3, which would be 12. And then times 10 would be 120. And then we're going to divide this by 6. Okay, so now let's come back up here. And now we have x equals negative 4 plus or minus the square root of 136 divided by 6. Okay, now we could leave this as our answer, or you could simplify a little bit if you wanted. A couple different ways you could simplify. If we wanted to just say, see how we have like a 4 over 6 there? We could say this is negative 2 plus or minus the square root of 136 over 3. Basically, we simplified 4 over 6 there to be 2 over 3. And we could leave it like that. Or you could simplify the square root of 136. So if we take 136 and divide it by 4, reason why 4 is because 4 is a perfect square, right? Then it would be 4 times 34. And so we could write this as x equals, and let's circle this one for now. And let's go back to our original. Let's say negative 4 plus or minus. And now we're going to write this as 2 root 34 because we did 4 times 34 and the square root of 4 is 2. So this would be 2 root 34 divided by 6. And now we could simplify once again this 4 over 6, but we could also simplify the 2 over 6. So this would be x equals negative 2 plus or minus the square root of 34 over 3. Okay? And so these two, essentially the same thing. Also, this would be the same as well. We've just simplified a little bit there. So we have 2 solutions there. We have negative 2 plus the square root of 34. And so we could do that in our calculator, negative 2 plus the square root of 34. And then we divide that by 3. So we could leave this as our answer, or we could say x is approximately 1.28. And then we have negative 2 minus the square root of 34. Divided by 3. So this would be negative 2.61. So if we wanted to round our answers, we could get a decimal approximation. All right, for example 2, now we're going to have 1 real solution. So once again, we want to make sure our equation is equal to 0. So let's add 13x and add 16 to both sides. Okay, so now we have 4x squared plus 3x and 13x would be 16x. Plus 16 is equal to 0. And now we're ready. We can say x equals opposite of b, so negative 16, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So we get x equals negative 16 plus or minus 16 squared would be 256. And now notice here how we have minus, and we have just a negative 4, a 4, and a 16. So there's 1 negative there. So that answer is going to be negative. So it's going to be 256 minus, and once again, this is 16 times 16. So minus 256, and we're going to divide by 8. Now we get negative 16 plus or minus, and this is going to be the square root of 0, right? And that's essentially going to go away, and that's where our one solution comes from. So we get negative 16 over 8, which is just negative 2. So negative 2 would be our only solution for that example. All right, and last example, number 3, we're going to look at an imaginary solution. Once again, we want to make sure this is equal to 0, so let's add 1 here. So now we have 5x squared plus 2x plus 1 is equal to 0. And now we're good to go ahead and use our formula. So we have x equals opposite of b plus or minus b squared minus 4 times a times c. And we're going to divide that by 2a. So we get x is equal to negative 2 plus or minus 2 squared is 4. And this would be 4 minus 20. And now we're going to divide that by 10. So we get x equals negative 2 plus or minus 4 minus 20 would be negative 16. And we're going to divide that by 10. So now negative 16, our discriminant is negative, so we don't have a real solution. So this is where our imaginary solution comes in. And we have x equals negative 2 plus or minus. The square root of negative 16 would be like the square root of 16, which is 4, and the square root of negative 1, which is I. So we could write this as 4i divided by 10. Now we can simplify this, and we could write this as x equals, and like negative 2 over 10 would be negative 1 over 5, right? And then 4 over 10 would be like 2 over 5, so plus or minus 2i over 5. And that would be our two solutions there, and those are imaginary, right? We had negative 1 plus 2i divided by 5, and negative 1 minus 2i divided by 5. And that's how you can use the quadratic formula to solve quadratic equations.